Hello, Ted. Hello, Larry. This is Fred in my kitchen laboratory again. I wanted to show you a very similar setup to I showed before. This is the same setup as before. There are two plates, brass plates on top of each other, and there's sandwiched between each plate, stacked in two pieces, are fluorescent lamps, 5/8 of an inch in diameter, and I'm turning the bottom one on and varying the current just like before. And the difference is this is not 10 gigahertz, this is 24 gigahertz. I guess Ka band instead of, or some K band instead of X band. I'll take it apart in just a minute. So it's the same thing. The got the transmitter, and here I've got a receiver horn. That's an X-band horn, but it's got enough sensitivity at 24 gigahertz that it still works. And it's at about a 15-20 degree angle from the transmitter. And then I've got the oscilloscope hooked up to the diode. So I'm going to start increasing the current. That's 20 milliamps. Oh, I think I have to turn on the diode transmitter. Yes, that's the transmitter for the gun diode. Okay, so that's about 15 milliamps, and that's that is 60 milliamps there, 100 milliamps, and 150. So there seems to be some diffraction and some beam steering. You can see the instability like before. I'm going to turn back down. And that's zero current in the plasma. So again, 0, 10, 20, 60, 80, 100, 150 milliamps. It's still going up. If I had more current to give the plasma, I'd probably get a bigger signal. Okay, so let me turn off the diode transmitter, and I have an aluminum shield over the stack. I'm going to take that off. So that aluminum shield was to keep stray microwaves from coming off the top, because what I have is a gun diode, no horn, just a gun diode, and the open waveguide sprays into the input of my stack of plates. So the aluminum foil was to keep stray microwaves from coming directly from the diode. So that's I think that's very interesting. We're getting appear to be getting beam steering at 24 gigahertz with this pretty crude big lens. And it's interesting, this actually works better, it's easier to set up than the 10 gigahertz. And I think part of the reason is this, I think the 24 gigahertz is about what, 12 millimeters, 14 millimeters. So that's half the wavelength of the X band, the 10 gigahertz. So there's probably not as much uh, diffraction of the microwaves out of the transmitter end. So and I'm not sure, but it appears to be working better. Uh, Larry, I'm still having trouble working with the with the ballast uh, variable intensity uh, power supply. I'm going to try it again. It works. I'm having trouble with it being very reliable. And the other thing is, what I've got here is actually a turntable, and I'm not using it as a turntable because the E field needs to be vertical, and in order to use the turntable I would need for the E field to be horizontal, and I just need to make a jig or somehow figure out how to get the how to get the turntable to work the way it should. Just wanted to catch you up on the crude experiment here. Thank you.